I recently went through an exercise which I thought could serve as a good model of incremental development. So I thought I would present it as a video. And the goal of this project is just to list the prime numbers from the first one, 2, up to whatever number you specify. And a good way to do incremental development is as I put it, to hide the hard stuff until the end. Just start from the outside and work your way in, and I'll show you what I mean by that. We'll create a class, and we'll call this prime list. And I'll put my name in here, and today's date in standard format. And I'm going to strip out all the boilerplate code they provide here. So now we could start this class by using the standard main function, which is public static void main, and with a list of strings as arguments. But we'll take advantage of the fact that we're using BlueJ and use a non-standard main function just to pass along the maximum number. Now this would not work if we ran it as a class by the command line, but we're not going to do that. So we'll just give it the argument instead, integer max. And just to make sure we've passed it in correctly, we'll just print it out. So that's about as simple-minded a first approximation as you could come up with. All it does is prompt you for the maximum number and then print it right back out at you. So let's just go ahead and do that. Let's choose 15, and 15 is what we get back. Nothing too big a deal here. Okay, for the next step in refinement, we'll loop through all the prime number candidates up to the maximum. So we'll write a for loop, and we'll use an int. We'll call this test num, because even though we're not testing it for being prime this round, we'll test it later. Lowest possible prime number is 2. We want to generate these up to and including the maximum and increment. So we'll use this print statement to print out test num, just to make sure we're generating the right range. There, that should do it. Now let's see what we've got. Compile's okay. Let's run it. Let's go up to 12. And it generates the numbers from 2 to 12. Fine. Now all we have to do is test each number for being prime and only print it if it is. So let's make up a test function. Say if is prime, and we'll pass it the test number. And this should return true if the number is prime, and false if it isn't. So in this case, we're still deferring the logic of this. We've simply defined the function. So let's define it down here. So make it public It has to be a static because this belongs to the class and not to a particular object. Returns Boolean. And the name of it is prime. And it takes an integer. And let's call it the candidate. And now before we refine this, let's just have it return true. This is what we call a stub. We have stubbed out this isPrime function to fit in where we're calling it, just to test that everything is syntactically okay, but it doesn't do anything. It just returns true all the time. So we should see the same result as before. Run main, type in 13 this time, and again we get all the numbers. Alright, now we have to think about how we're going to determine whether this number is a prime. So what we really have to do is go through all possible divisors up to just below the number itself, and if it has any even divisors, then it's not prime. So that kind of implies that we're going to have to do a loop. So we'll do for int, we'll be looping through candidate divisors. The first possible divisor is 2. The maximum divisor is 1 less than the candidate itself. So this is the cutoff condition. And then we increment the divisor. And I've got a little typo there. Okay, now how do we test for an even divisor? Well, it so happens that the percent sign, also known as the modulus, basically returns the remainder of a particular division. So if that returns 0, the remainder is 0 and it's an even divisor. So if our candidate and we use the mod operator and the divisor. If this is 0, then we found an even divisor and we can return false right away. And if we get through this loop without finding a divisor, we can return true because the number is in fact prime. So let's see if that works. Okay, well, I'm familiar enough with the primes below 20 to know that that's correct. So we have achieved success here. So I hope that gives you a little bit of an idea of incremental development.